Then secondly, they ask us now, write down the area of triangle AOM, which you see is the top one, compared to the area of triangle ABC. So, okay, now we can start writing down the answers. We know this value here, AM is equal to 3, right? So if that is equal to 3, then we know obviously MC is going to be equal to 3. Are you with me, guys? So if we need to work out what is the one area proportion or the ratio from one to the other one, then all that we have to do, we work with right angle triangles. So the area of any right angle triangle should not be a problem, right? We know the area, because the area of a right angle triangle says it's a half base times perpendicular height. So if we take the area of triangle AOM, then the area is equal to a half base times height, right? The same with the area of ABC, it's a half base times height, right? It's two triangles with 90 degrees. So what is the base of the small triangle? Remember, we work with AOM. Let's have a look at it. It's a half times my base is, there you can see is 4. You with me? Times what is my height? There you can see is equal to 3. You with me, guys? 2. Let's look at the big triangle. The base, there we have it. It's times 8. And what is the height? Is a 3 and the 3. That gives me 6. And therefore we can write down 4 times 3 is 12, and half of 12 is 6. You agree with me? And there we can say 8 times 6 is 48, and half of that is 24. Or we can say half of 8 is 4, and 4 times 6 is equal to 24. And then we can just write that in a simpler form, that 6 is to 4, 24 is the same as 1 is to 4. And remember, how do we do that? We divide both sides by 6. So the area of the one triangle to the area of the big triangle means 1, 2, 4. And again, learners, it's just a matter of, do I know some of my information? Just see some of the questions here. Let me just go there. There's some of the guys that says or ask, this is not paper 1, guys. It is paper 2. Right? It is paper 2, remember? Euclidean geometry. Your paper 1 consists out of 6 other components. Paper 2, 4 components. And Euclidean geometry, remember there's also the analytical geometry. So the Euclidean geometry is the last part. We're talking about the circle geometry, where all your theorems are. This is applicable. This is grade 12 work. You had to cover 2 grade 12 theorems. The proportionality, and obviously I'm going to do the similarity. So it's fine. I hope that is what answer your questions, but thanks for the comments, guys. Let's look at one challenging one. A challenging question here. If you look at the sketch alone, you're going to say, sir, it looks frightening. How do I approach a sum? Always try to understand and study your sketch so that you know exactly what to do if you have to answer. It says here, GB is parallel to FC. Now, if I just keep this part away, let me just use something else. Let's look at that. Can you see this triangle AFC? GB is parallel to FC. There it's being indicated. Now remember, the theorem that says if one side is parallel to a side of a triangle, you can write down a proportion. Now remember, ignore this line here. So what is a proportion? You can write down AG over GF equals AB over BC. And again, there can be few other corollaries. But just because these two are parallel. Now, if I close this side, can you see EB is parallel to DC. They give you that, right? EB is parallel to DC. So top part is AE over the bottom is ED equals to AB top part over BC. So it's just one way of looking at this. So as you can see, try to get the understanding of your sketch. From there, let's write down more information. It says there, AC is 6 centimeters. Now let's just take this quickly and I make it nice and clear for you. What is AC? It is this whole side there. Right? That whole side AC. There they tell you that is equal to 6 centimeters. Right? Then also what they say is that AB over BC is equal to 2. Now, if we say AB over BC is equal to 2, we obviously know that it is the same meaning as 2 over 1. Any value means a value over 1. Now, it's AB over BC. It has a ratio 2-ish to 1. Right? It's given there. Right? So, how does this work? If the whole side is 6 centimeters, but we have a ratio that says the top compared to the bottom is 2 to 1. This is half of that. So in terms of centimeters, if the whole one is 6, then BC must be half of AB. But they must add up to 6. Now if I have to write that in terms of centimeters, AB versus BC, can you guys send me quickly that answer? Let's just look at it. If AC is 6 centimeters, but AB, according to BC, has a ratio 2-ish to 1. Can you see that one is double that one? Then what is the centimeters of AB and BC? What are the centimeters? While you think, let me just look at what they ask. 3.1, calculate the reasons of AH, there's AH, over ED, right? And there, the answers is flying in. Martha said, sir, that is quite easy. I don't have to even think. Other answers are coming through. Jamangile, AB is 4. Okay, I don't know the names. Please, guys, sometimes just or write in your names. Bishop Demont, Imtiza, the answers are all coming through. Thank you, guys. Perfect. So if it's 2-ish to 1, you agree with me. So that's going to be 4 centimeter versus 2 centimeter. I mean, that is logic, right? This one is half of that. So 2 is half of 4. And together, they form 6 centimeters. So you see how you need to work with these sketches. If you work like that and understanding, then you can see it's not so hard. Now let's look at the question. AH over ED. Now, the ratio, let's just cover this part again. The ratio of AB over BC is 2-ish to 1. Now, those are my parallel sides. Let me just add it here also so you can see. If this side is parallel to that one, then the ratio of this is equal to the ratio of that. So if that is 2-ish to 1, I can also say that is 2-ish to 1. Are you with me? Now let's just, to make us not confused, let's write 2y over 1y. Remember, that's not centimeters. It is just a ratio, right? So now we have AH, which is the same as that, right? And then HE, which is the same as BC, right? Now, how can we write down or start writing down this? We can write down now AH, just with me here, over HE is equal to 2 over 1. AH over HE is also 2:1, right? Or maybe I should write down as 2y over 1y. Why do we say that? Because of HB, remember your reason? This HB is parallel to EC. Remember, whenever you write down a proportionality, just make sure you understand that. So what can we derive from that is that, give me another color, so AE over ED, right? Let's do AE, right, over ED. It's again, if you look at that triangle, there's my two parallel sides, that one and that one. It's 2:1. So AE over ED, we can also write is 2:1, right? And for that reason, obviously, we know that BE is parallel to CD. Right? So just take note, guys, how we work with that. So then if we go from there, then we can see that to that is 2:1, which means that whole part there, it's 2-ish, and that whole part there is 1. Now from there, we can now start writing down. So then ED, if we cross multiply, remember, because we can do cross multiplication, we're going to work out that ED is going to be 1,5. Remember, if you cross multiply, we can get to this answer. And therefore we can write, so AH over ED, what gives you 2 over 1,5. And therefore, if you want to write that as a nice number, we can just multiply or double that to get rid of the decimal, but we can leave it like that. If you multiply the top part by 2, we can get 4. If you multiply the bottom by 2, we will get obviously equal to 3. So there are learners that gave the answer 4 over 3 or 4-ish to 3. And that's exactly what we want. All right. All right, guys, let's just go to the second theorem so that at least I can cover that. We don't have a lot of time. Let's just look at the last theorem. Let's look at the PowerPoint.